Point number 9. Number of elements in set A is denoted by n of A. Now, lo sabe lo number of elements inside the 1 plus set. Imo beta, the set is defined using a roster form. So, thingy me look lo triple way where you can define him set. Number 1, you may list the elements or roster form. Number 2, using set Bela notation to define him set. And number 3, you may describe him elements to define him set. So lo here, suppose you may like find him number of elements inside the 1 plus set. It's a must where you must write him set in roster form past time. So now by me look sample example. Now this like example A is equals to the set 1, 3, 5, 7. Okay? The number of elements in this set now will be, you may count them element 1, 2, 3, 4. Number of elements in set A is equals to 4. You may look narapla example. Set B is equals to the set of letters in the word spheres. Now, this set is given by describing the elements inside the set. So, before you may find out number of elements, this is set B, you must write him in roster form. Write him also. So, by me write in roster form, thinking, you may look in finish, osem, suppose all letters identical or same elements inside the set, you may by writing 1 plus time that's all inside the set. So set B now and by equals to is equals to the set SPHER. So you may count the elements 1, 2, 3, 4, now 5. Number of elements in set B will be equals to 5. You may look at another example. C is equals to the set X such that X is a natural number. Now by you may write him this last set in roster form. Set C is equal to 1, 2, 3, 4, 5, 6 and then continues. Because set and we define lo here and we talk X is a natural number. So M by including all get a natural number. Now number of elements in set C now will be number of elements in set C will be infinity. We look at narapla example again. Set D is equals to the set X such that X is an integer and 3X is equals to 5. Now before you may list them elements to this set, but you must solve this equation past time. 3x equals 5, x equals 5 over 3. X is an integer. Now look here. Time you may solving this equation. X is equals to 5 over 3. Now 5 over 3 is not an integer. Set D now is equals to null set. You make it write the osem, or you make it write the osem. Number of elements in set D will be equals to 0. Point number 10. Two sets are equal if they contain exactly the same element. So 2 plus set number equal, suppose elements below. Example set A and same small elements inside the set B. So by me writing osem A equals B. Now suppose set A equal to set B, then by you may write him osem. A is not equal to B. You may look at a sample example. Example 1. Set A is equals to the set 1, 2, 3, 4. Set B is equals to 4, 1, 2, 3 plus set A and set B. Look at all elements. Elements inside the set A. Now look at elements inside the set B. Each individual elements lo set A. Like 1 here. And you can find him inside the set B. 2 here, you find him inside the set B. 3 inside the set B. 4, 2, you find him inside the set B. So by you may talk, set A is equal to set B. Narapla example. Set G is equal to the set CAT and naket. Set H is equal to set A, T, na C. Now you may look at this 2 plus set. You may get element C here, lo set G, and you may get him 2 lo set H. You may get A lo set G, you may get 2 lo element A lo set G, you may get him 2 A lo element inside lo set H. T lo here, and T lo here. But lo here, cat, you may not get him lo here. So this like mean osem. Set G now is not equal to set H. Point 11. If every element of set A is also an element of set B, then set A is a subset of set B. So by using this last symbol, set A is a subset of set B. Okay, by mixing back example. Now you may look here, previous example. Set A and set B. Every element in set A is also an element of set B. So you may by writing this la 2 plus set na osem. Set A is a subset of set B. Point number 11. If every element of set A is also an element of set B, but set B has more elements than set A, then set A is a proper subset of set B. You may write him osem. A is a proper subset of set B thing. All the element law set A are also element of set B. But set B, you got 1 or 2 or 3 or plenty more element where you know not painim no set A. And meaning no proper subset. So set A is a proper subset of set B. So set A got more element inside the set B. But set B got more element where you not painim to law set A. So by me writing also. You may look sample example. Here you may get him 3 plus set. Set A, you got him elements P, Q, na R. Set B, you got him elements Q, R, na P. Na set C, you got him elements P, Q, R, S, na T. Now, suppose you may look. This all elements. Now, all sets. Where you may look at set A is equals to set B. Because all the elements plus set A. And we say most small elements plus set B. So M by you may write him osem. A is a subset of set B. Now you may compare him set C 1 times set A or set C 1 times set B. Suppose you may compare him this la 2 plus set 1 times this la set na by you may find him osem. All elements plus set A na set B. You by find him that's all sampler all these elements inside the set C. So this like mean osem. Set A is a proper subset of set C. You may write him osem. Or you can write him set B is a proper subset of set C. Why? Because set C, you got him supply elements where you know painim inside the set B. So you're looking Q R na P, Q R na P inside the set C. But S na T, you know painim inside the set A, or you know painim inside the set B. So by you may write them also. Point number 13, the universal set is denoted by this symbol here. It's the set that contains all elements being considered in a given discussion. So this is a symbol. You may denote him universal set. One very important point, empty set is a subset of every set. So this is like one very important point.